Welcome back again to another Java short tutorial, and in this tutorial I'm going to make an introduction about inheritance between Java classes. Okay, so let's go back to the example that I used in my previous two videos, the example of a student. Say if I would like to create another class called staff. Of course I could create, just like I did with student, create all the attributes that I would like to have in this class and generate the getter and setter methods and so on and so forth. But if you think about it, there are a lot of attributes that actually overlap, like name, address, age and phone number. So would it not be convenient that we don't have to repeat all of that code? So that's where inheritance comes in handy. So if you think about it, a staff and a student are both persons, and a person has this basic information that we talked about. Okay, so let's now just completely delete this student class I've created and leave this staff class empty as well. And of course that's going to affect my student test script, so let's just delete that too. So I'm going to leave the student class empty for now and the staff class empty for now, and create a additional class called person. And of course person has the name, has an age, has a address, and has a phone number. So let's create some getter and setter methods for that. Okay, so there's the person with all these qualities. So how does inheritance work? Well, inheritance works very much like inheritance in nature. So you have what we call a superclass or parent class, which in this case is person. And this superclass or parent class passes on its qualities and attributes to the child or subclasses. In this case, students or the student and the staff class. So essentially you can say student is inheriting properties from a person, because a student is a person. And since staff is also a person, they are inheriting the general qualities of person. And as a result, I don't need to define them in those classes itself. So how do I go about that? Well, basically I say student extends person, meaning student is inheriting everything, all the qualities and properties and attributes of person to himself, which only leaves me to define what makes a student unique. So what is the quality that only a student has? So in this case that would be a student number, for which I will once again generate a getter and setter. And what makes a staff unique? Well, a staff has a staff number, and maybe an integer years of service. So let's create a getter and setter for that as well. Oh, wrong button. So there are the getters and setters for these attributes. And since a staff, like I said, also is a person, he will also extend the person class. Okay, so now how does that affect the program? Okay, let's go back to my student test, which I will rename using the refactor operation to person test, because we are no longer just testing students now. Okay, so let's first create an instance of student. So student1 equals new student, bracket bracket. No constructors in this case. I'll probably cover that in my next video. So student1 dot set name. So we had Jon Snow. Student1 dot set age. So yeah, as you can see, since a student is a person, all the attributes and getter and setter methods that I've defined in person can also be accessed through the student class. Why? Because a student is a person and therefore has everything that a student has, a person has. So let's give him the age 35. But he also has the set student number, which is the one method that is uniquely to the student. So set student number, again ABC1234. Okay, so now to indeed prove that this works, I'm going to write a system.out.println line, student name plus student1 dot get name. Okay, and to hurry things up a little bit, I'm going to copy this. So the name, student age dot get age, and last one, the student number, which is student dot get student number. Okay, let's do the same thing for staff before I run this, but I will do a blank system.out.println line in between them, just to make it look better in my console. So let's create an instance of staff. Staff1 equals new staff, and staff1 is going to have his name set. So Ned Stark in this case, and the age 45. Then one of the attributes that makes the staff unique, so the staff number P001234, something like that, 1236. Staff dot set years of service, let's say 15 years. Okay, then another battery of system.out.println lines just to prove that it all works. So I'm going to change this to staff1 get name, staff1 dot get age, staff1 dot get student number, which doesn't exist because student number belongs to student. In case of staff, it must be get staff number. Then lastly, one more, years of service. Forgot the double dots here. Staff1 dot get years of service, and don't forget the semicolon behind there. So that's staff name, staff age, and staff number. Okay, so now let's run this. Why does it not? Oh, wrong class. Person test, run as Java application. So there you have it. Student name Jon Snow, age 35, student number ABC1234. Then staff name Ned Stark, staff age 45, staff number and years of service. So there you have it. You can create a superclass or parent class which has certain generic qualities, which can then be inherited down by multiple classes, and as a result the properties of the superclass can be used as if they are part of the sub or child class. So that's all for an introduction to inheritance. See you next time.